Hi everyone. In this video, we are going to solve a problem. The problem name is lexicographically smallest equivalent string, and the problem number is 1061. So let's quickly see what this problem say. We are given two string of same length S1 and S2 and a string base string. Alright, so we are given with the two string. One is S1, second is S2, and they are going to be a same length. So the length of S1 is let's say 3, then the length of S2 is also going to be 3. And we are given with one another string that is base string. Okay, so the length of this string does not depend on S1 and S2. That is clear. Now it says B say S1 of I and S2 of I are equivalent character. And what is equivalent character? Let's see. They are given one example. So I'm going to say S1 is nothing but ABC. You can see the example. And here. And S2 is nothing but CD. So S2 is nothing but CD. Fine. On 0 index, we can say S1 has A. On 0 index, S2 has C, right? So they are going to be equivalence. So on 1 index, we can say B. And on 1 index, S2 has D, right? So let me write D. So they are going to be equivalence. Again, on second index, we have C. So S1 has C and S2 has E. So they are going to be equivalent. So what do you mean by this equivalence? Let's try to see first of all. So let me remove all these things. They're telling us three terms. You can see reflexive, symmetric, and transitive. What does they want to tell us? So for reflexive, let's say we have a string. Let's say same again. I'm going to take ABC and CD. Right? Let me take another string. Let's say A, here E, here F. Okay. So guys, you can see that on zero index we have same string, right? So they are going to be equivalence. Or if you get a same string on the same index, so they are going to be equivalence. Here A, that means A is equivalent to A. If I take any other character C, and other string also have same character on the same index, so they are going to be equivalence. That is nothing but reflexive. Okay. Symmetric for this, let's say you have a string A, and that is equivalence to B. Now, if A is equivalent to B, then we can say B is also going to equivalence to A. That is nothing but symmetric. Now, what is transitive? So, let me write here A is equivalent to B. And if B is also equivalent to another one that is C, then we can say A is also going to equivalence to C. If A is equivalent to B and B is equivalent to C, then A must be equivalent to C. That is nothing but transitive. So, same thing written over here. Alright. Now, guys, they're given one example. So, in that example, they're given S1 is nothing but ABC. So, let me write A, B, and C. S2 is nothing but CD. Now they given a base string that is nothing but EED, right? So let me write EE and D. Fine. Now guys, they have given these three things, and we have also learned that S1 and S2 are going to be same length, and base string is going to be a different or maybe same, right? So now we have to find the equivalence. So we can say A is going to be equivalent to C, fine. B is going to equivalent to D. We have already seen on every index we can say the one character is going to equivalent to another character, right? And C is similarly going to equivalent to E. So we have these three things so far. Now we have given a base string that is EED. Now we have to generate so many strings by using this equivalence. So on first character we have E, and E is equivalent to C as well, right? And this C is also equivalent to A. So let me use a different color. So here guys, we have E and E is equivalent to C. So in the place of E, I can write C, isn't it? And after that, again in place of E, I can write C, and D in place of D, I can write B because they are equivalents, right? So we are getting a one string that is CCD. So far so good. Now guys, we can generate more string. Here in place of E we can write C, but in place of C also we can write A, right? So I can write A, and in the place of E again I can write A, and in the place of D again I can write B, right? I can also do in the place of E, first time I wrote A, and the second time I am writing C, after that I am writing B. Now guys, why we are generating this string? See guys, we have to return the lexicographically smallest equivalent string. That was the question mean, right? Return the lexicographically smallest equivalent string of base string by using the equivalency information from S1 and S2. So now we have to return the lexicographically smallest string. And here, so far we have just calculated 3. And we can see that the lexicographically smallest string is nothing but AB. This one is starting from C, and you can see C is greater than A. So this is not going to be lexicographically. And here it is going to start with A. So far so good. We have two string, and both are starting from A character. And after that we are getting A, which is a lexicographically smaller than C, right? So we can say this is a lexicographically smallest string. If we generate a more string by using this equivalence relation, they are not going to be lexicographically smaller than this one. So far we can return AAB. So this is also telling us that AAB is lexicographically smallest equivalence string of base string. I hope now you understood the question. This is what question want to tell us. And I believe now we can move to the logic part, how we can solve this particular problem. So let's quickly see what is the logic for this particular problem. So guys, let me write here logic now. And in this logic, we are going to take this first example, and we are going to see how we can solve this particular example by our algorithm. So we are going to take S1. S1 is nothing but Parker. So Parker, let me write here Parker. Fine. Now guys, another one is Maurice. So let me write here Maurice. Okay. Now we are given the base string, but don't write it for now. We will see it later on. Now guys, see what we are going to use. We are going to use one algorithm, or we can say technique, that is union find. So what is this union find? First, let's try to understand this problem. Union find help us to find the root of any particular nodes, characters. It is mostly famous in graph, but we can use this algorithm to solve this particular problem. because this is nothing but, let's say these are nodes. P is a node, A is a node, R is a node, right? So this is nothing but nodes. For this algorithm, consider all these characters are nothing but a node. Fine. Now what this union find do? So let me tell you in a brief. So there is one function union and there is one function find. Fine. So first of all, we will use this function to find the root of particular character. So for P also we will find the root, A also, R also, K also, E also, R also, and same for all these characters. Once we find the root, we can see that this particular character belong to that particular root. Alright. So by this we can replace our character with that particular root. And I know this might be confusing for you because this is a bigger term and you haven't seen right now how we can use in this particular problem. But once you do the code and you will write same function in your code, then definitely you will have a better idea how we can solve this particular problem by using a union find. So now let's quickly see how we can do this. See guys, first of all, I'm going to say find the root of P. And initially we have a dictionary that is empty, fine. And the root of P is nothing going to be itself. If we doesn't had a P in our dictionary, means there is no key present with the name of P. Just write the same character with that particular key. Fine. Now guys, after that we are going to find the key of M. We are going to do only for 0 index right now. Alright. So for 0 index, the P root is going to be a P and the root of M is going to be M. So far so good. We don't have this key exist in our dictionary. Fine. Now guys, once we find the root, we can say the root of P is P and the root of M is M. The root of P is P, root of M is M. Then which one is smaller? P or M? You guys can see that M is smaller. So we can see that if M is smaller, then the bigger one P, just write there M. P is now have a root nothing but M. Alright. Now let's quickly see the another first index. Here we have A and A is not present in our dictionary. So we can say guys, on A we have a root nothing but A. On O also we have root nothing but O. Now guys, you can see that we have a root A and O. Which one is smaller? A is smaller. So we can say replace O key with the A. So O is now having a root A. After that we can say R and both are having R. So let's write just R pointing to R because we don't need to compare, both are same. So no one is smaller, no one is greater. So R key is going to be point to a root R. Now another index, nothing but third index has a key K and this one has R. So initially K is not present in our dictionary. So we can say K's root is K and R is present in our dictionary. So R root is nothing but R only. Okay. So we can say R root is nothing but R only. So we can now compare these two terms and we can say K is smaller than R, right? You guys can see that K is smaller than R. So what we can do? We can replace R with a K. Okay. Now we have a fourth index. On fourth index we have E and here I. Now guys, you can see that E root is nothing but E because it doesn't present and I also root is I because I also not present in our dictionary. Now the E is smaller or I is smaller. You guys can see that E is smaller. So what we can do? We can replace I with the E. So we can say now I is have a root nothing but E. Again the fifth index has a value R and here S. Now R is present already and the root of R is nothing but K. Fine. Let me write here because it is not going to be a little complex. And here we have S and S does not present. So S will have a root nothing but S. Now guys, we have one K and another is S. Which one is smaller? K is smaller. So we can say replace the value of S with K. So now S will have root nothing but K. So now we have traversed all the string. We have find the root of every character. Now we can quickly write our base string. So let me write a base string. Fine. This base string is nothing but parser. So we can write here parser. Fine. The root of P is nothing but M. Okay. The root of A is nothing but guys A. Fine. The root of R is nothing but guys K. Fine. The root of S is nothing guys K. Again. The root of E is nothing guys again E. Root of R is nothing guys K. You guys can see that again K. So we are getting a string nothing but make it, right? M-A-K-K-E-K. And in the output as well, you can see that we got output make it. M-A-K-K-E-K, right? So this is how we are going to solve the problem. On every particular index, we are finding first of all root of every character. After that, we are calling our base string and we are trying to find again the root of every character and just adding in our final out. Now let's quickly see in the code how we can write this particular logic, how we can use a union find algorithm, and how we can solve this particular problem. So now guys, first of all, you have to understand union and find. So let me write here first of all union. So what did this union function do? Union function will call find and this function find function will return the root. So let me write first of all find. So I'm going to say define find and this find function take a character, all right, and after that this character is going to return the root. So let me write here return root. Fine. Now guys, this union function will take two character as I have told you, the character of first string and the second string. So let's write ch1 and ch2. And what this will do, this will going to map particular character with a particular root, right? First of all, let's create a dictionary. I have told you initially we are going to create an empty string. So I'm going to give a name dic and after that in this is going to be empty. And finally, if we try to find a character, how we can find it? We can see if character is not already present in our dictionary. So what I'm going to do, I'm going to replace that character with the same root, right? If ch not in dictionary, let me write not in dictionary. So what we can do, we can say dictionary of ch is going to be same. All right. Now guys, if it is not the case, Then what we can do? We can say to find that particular root of that particular character. So we can say if ch is not equal to dictionary of ch, that means if the key and value are not same, what we can do? Now we can say dictionary of that particular ch means now we are going to replace that particular root with the root present on that particular key. I know it might be complex, but let's say if I call this function find, and here if I pass dictionary of ch, that means I am just saying that of dictionary of that particular character means the root value of that particular character is going to be replaced by the root which is going to be written by this find function. Now this find function is written a root, so that is nothing but dictionary of ch. I hope this much is clear to you. Now guys, once it return that particular character, we are going to say find the root of both the characters. So I'm going to say find of ch1, find for ch1 and find for ch2, both the character. Once I have both the root, let me write here first root, or let me write ch1 root. Sound will be more clear, ch1 root. And another one is going to be ch2 root, right? Ch2 root. Let me write root. Fine. Now once we have the root for both the character, we can say if the first root is greater than second root, if I write ch1 is greater than ch2, then what we can do? See guys, if ch1 is greater than ch root, that means we have to map a greater root with a smaller one. So we can say dictionary of ch1 root is nothing is but ch2 root, isn't it? And if it is not the case, if ch1 is smaller, ch2 is greater, then we can say ch2 root is nothing but ch1 root, right? Replace that particular root value with the ch1 root value. Fine. Now once we have done all these things, what we can do? So I'm going to say for I in range of length of s1, or you can write s2, both have same length, and call this function. So I'm going to say union, first of all s1 of I and s2 of I. So I have called for every function, I have the root of every key right now. Once I have the root, I can say I'm going to define my output variable. So that is result, and this is going to have an output result. Now I can traverse our base string. So I can say for I in range of base string, just for every character you have to find the root and add in our string. So I can say result is going to be equal to result plus equal to find the root of every character which is present in base string. So base string of I, and you have to just return that one, return result. I hope this much is clear to you. Let's try to see if we have any error or not. So we have an error that is base string. Okay, I have to use a length of base string. Fine, let's try to run now. Now you guys can see that all the test cases are passed. Now guys, let's try to submit this code. And here we go guys. You can see that it's successfully accepted. And I expect guys you understood this problem. If you still did not understood, you can write in the comment section. I'm always there to help you. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.